And we're live once again. Welcome to another episode of the MongoDB Podcast Live. Today we're going to dive into the world of vector search with an Ask Me Anything. So bring your questions. Hat tip to Jesse Hall and Luce Carter. They'll be moderating today. And our guest, let's get right to it. We've got just about 60 minutes, so we'll try and get to all your questions. But before we do, let's bring our guest of the day in. Ben, welcome to the MongoDB Podcast. How are you?
Doing well. How are you?
I'm doing great. It's a great day. So we're going to dive deep into the world of vector search, MongoDB's vector search product. And I'd like to ask you first to introduce yourself to the audience. I'm sure many of the folks joining may have been on the previous webinar, but for the folks that don't know, let folks know who you are and what you do.
Sure. Hi, my name is Ben Flast. I'm on the product team here at MongoDB, and I work on a range of features and capabilities inside of the platform around search, vector search, and AI. And yeah, super excited to be here.
Yeah, fantastic. All right, so vector search. It's at the heart of AI, and it's all the rage, all the buzz these days. Before we get into the questions, we've got some prepared questions, some leftover questions from a webinar. Really great questions, by the way. We're going to get into those and answer yours. So get those ready if you're joining the stream. But for the folks that are joining or that are just interested in vector search, maybe give us an explanation. What is vector search and how does it relate to MongoDB?
Yeah, absolutely. So vector search is a newer approach to doing retrieval, which allows you to basically take any type of media or content, embed it into a vector using a machine learning algorithm, and then search on those vectors using a k-nearest neighbor or approximate nearest neighbor algorithm in this situation to basically find similar things to the target based on how far away the thing that you're searching for is from the targets inside of your collection, based on that distance between vectors rather than kind of specific keyword searching or filtering or things like that.
So when you say distance, we're talking about proximity in terms of relationships in the definition of the words, right?
Yeah, absolutely. So with vector search, you take your data and you convert it into these high dimensional vectors, and then you calculate the distance between vectors, right? And the way that you calculate that distance is using a function that's either, kind of a Euclidean distance, the cosine distance, or the dot product distance, which is kind of also called a similarity function. And all of this is something that you define inside of your configuration for vector search. And then that is what is used to kind of determine things that are near or far from one another.
Mm-hmm. So context matters, right?
Yep.
And as it relates to MongoDB's vector search, the key is that you can provide that context with your operational data source. Is that right?
Yeah, definitely. I mean, with respect to kind of MongoDB and how it all fits together, one of kind of the most kind of convenient parts of our solution is that you can store your vectors directly alongside your operational data. So whether it is your kind of chunked articles or chunked text, whether it is image files or anything that you can store in MongoDB, you can now store the vectors based on top of it directly alongside it. You can also just store vectors inside of MongoDB with references to other places. But in all of these instances, the flexibility of the document model allows you to kind of store a variety of data and shapes and sizes inside of your documents, and now have vector search on top of that.
Yeah. So we're going to get into some of the questions that we've got from the previous webinar. And some of them have to do with comparisons to traditional search. So vector search differs in several ways. Let's talk about that first. How does vector search differ from traditional search?
Sure. So with vector search, you're really searching on these, representations of your data, these vectors, which are, high dimensional vectors that represent the data based on some model that you've put that source data through, as opposed to, kind of a more typical keyword-based search where, you've kind of either tokenized your data and you're kind of matching on the specific presence of, a value or a field, or having the opportunity to kind of like boost the results of some specific kind of mention inside of a specific piece of text. Instead, you're taking kind of some larger corpus of text, creating an embedding, and then searching across them.
Okay, so let's jump into some of the questions. This one jumped out to me as interesting. The question is, why would I encode my data as vectors to search similar items instead of just fine-tuning an LLM?
Sure. So this kind of relates to one of the things that you brought up earlier around kind of context. So often people talk about vector search around the topic of providing context to these large language models, right? And so fundamentally, large language models are trained on some corpus of data and have access to all of the data that it was trained on. And they will basically, on top of their training, execute some sort of inference based on the question that's provided and give you back a response. Now, that is limited by the amount of data that they were trained on, up to how much data, and then also kind of the prompting that was given to that LLM. But if you want to kind of improve the accuracy of the results of the large language model, sometimes you want to insert context into, the prompts or queries. Now, you can do this by fine tuning, which would basically be kind of retraining or, training on top of the existing base model to make it know about new topics, or kind of include more private or sensitive data that you have for your company, et cetera. But the alternative approach is to do something called either retrieval augmented generation, sometimes referred to as in-context learning, where instead of kind of retraining the model, instead you kind of at the time of inference or at the time of the question, include kind of the context from your vector search. This is powerful because it allows you to, at any given moment, insert any specific new piece of data into your prompt or inference moment. It also lets you insert kind of private data that you don't maybe want the entire model to know about. And so in kind of a multi-tenant scenario where you're kind of having a lot of different customers that you're servicing at the same time, you're not going to retrain the model for each one individually and also kind of have like a cross-pollination issue. Instead, just at the time that customer asks a question, you want to be able to provide that customer's relevant data. And then lastly, just by providing content at the time of inference, you're further focusing the model on the specific question and the specific data you want that model to use at the time of inference to kind of just further focus it and reduce things like hallucinations. So there's really quite a few benefits. That's a set of three of them. But those are places where doing kind of retrieval augmented generation or in-context learning is kind of more appropriate or just has different kind of properties than fine-tuning.
Great. Okay, so for folks just joining the stream, we're asking and answering questions around vector search, MongoDB's vector search specifically. If you've got questions, put them in the comments. We'll try and get those answered. Meanwhile, let's take another from the list. This one is about recommendations for the size of embedding vectors, considering specific use cases. What are those considerations that we need to keep in mind?
Yeah, absolutely. So for those who don't know, when you take data and insert it into an embedding model or send it through an encoder, however you're referring to the model that's creating your embeddings, they produce these high dimensional vectors. And an individual model will produce vectors of a specific size. So, there'll be kind of 384, 768, 1536, a variety of different kind of widths of the vectors. Now, kind of conventional thinking is that the more floating point numbers you have in your vectors, the more data you can embed inside of the vector, and the more it can represent of the underlying data that went into it. And while that is kind of generally true, historically, we've seen kind of a pattern of diminishing returns. So after you get to X number of dimensions, adding additional dimensions does not seem to provide kind of additional semantic meaning inside of your vectors. And so it's not necessarily the case that just more is always better. And so that's one piece. So there's diminishing returns. On the other end of things, there's also just the fact that the more dimensions you add into your vectors, or the more dimensions you have in your vectors, the more data that they take up, which is kind of just a natural cost. And generally speaking, that's fine. But, at a certain point, you also then start to see kind of contention around concerns around just storing too much data and paying for unnecessary cost, both in terms of the amount of storage you have to pay for, as well as the fact that just moving more data around takes more time in a very fundamental sense. And so what you really want to do is find a model that best, solves your use case, provides you kind of high accuracy responses, which will in many situations kind of just determine the size of your vectors. So it's not necessarily something that you'll have kind of total control over, aside from picking which model that you want to use. But you also just want to be cognizant that the smaller the size of the vectors that the model produces, the more efficient you'll be able to store them and, potentially in certain situations kind of query them. And so those are really the trade-offs that you'll want to think about. And fundamentally, you just want to use the model that is best suited for your specific use case.
Okay. And where do folks go for information about models?
Yeah, absolutely. So we have a lot of partners in the space who are, providing models as a service, often available through, RESTful API endpoints. Popular ones are OpenAI with their A200 text embedding, as well as their kind of image embedding services. There are others like Cohere, which are providing kind of new and different embedding models focused on other spaces. And then there's things like Hugging Face, which is a repository for open source models, which is a great place to look and find models that you can use to embed your data that you'll then store in your database.
Great. Okay. The next one has to do with examples. And on the MongoDB documentation site and the product page for Atlas Vector Search, there are links to tutorials, and the tutorials reference some sample data. This question has to do with the samples and examples. All of the examples are for unstructured data. Does that mean if we have structured data, it can't be stored into VectorDB for ChatGPT queries? Yeah. Do you want to take that one?
For sure. So I think this is an interesting question. I think fundamentally where a lot of these embedding models really shine is around unstructured data. So you have large unstructured strings of text, right? Those are really, helpful to push through an embedding model to create a vector such that you could do semantic search on that kind of large corpus of data that was in an unstructured string. Similarly, you could say images, unstructured data. There's not kind of a straightforward way to search over images short of creating embeddings based on top of them and then querying against them. I think what this question is kind of getting at is that, generally speaking, you don't need vector search to search for structured data, because that is what, relational databases and, NoSQL and kind of general purpose databases all do very well, like what MongoDB does very well, where you can just filter on specific fields, right? And so if you need to find, a document where the value of name is Ben, then just filtering on that using a standard, MongoDB query or aggregation would be appropriate, and you wouldn't really need vector search. Now, the one thing that I will just say is that if you have kind of unusual query patterns that don't necessarily match to the structure of your data, then depending on kind of the lens with which you apply to queries on your data, you may find that there are ways that vector search does make sense. And so, for instance, you could think about a MongoDB document, being JSON and matching on a specific field, or you could kind of zoom out and think about taking that entire document and putting it through an embedding model, and then having a vector representation of the entire document, not just individual fields within it that you would match on. And so it really, boils down to the use case for the search as to where you want to kind of impose vector search versus not. And I think kind of the aperture of the lens of how you're kind of looking at your data as to whether it is a structured or unstructured type of problem.
Okay. Makes sense. All right. The next one has to do with availability of vector search, Atlas vector search specifically. Is there a free version?
Yeah, absolutely. So Atlas Vector Search is available in our M0 clusters, which are a free forever Atlas cluster inside of Atlas. Anyone can go in there, get started using them. You can use vector search on top of that. And I will just add in our sample data that we have that you can load into your M0 cluster does include a new collection, which is it's either embedded_movies or movies_embedded inside of the sample mflix collection, which is pre-embedded using the ADA002 embedding model from OpenAI. And so right there, just within kind of the free tier experience, you can go and have embedded data that you can create an index on top of and search directly using either some sample queries we've included in the documentation, or you can embed your own queries using the OpenAI API. Or you can go ahead and embed that data yourself or any data you want in the M0 tier and query it. But this is available inside of the Atlas free tier.
Great. So I want to pop this link up. It's mdb.link/atlas-free-vs-ama. I know it's kind of a long, short link, but if you want to jump in and launch your own Atlas instance and begin to play around with some of the sample data sets, which now include embedded vectors, you can do that for free using the Atlas free tier. All right. So the next question, let's see if we've got it all. Is it fitting? Yeah. Okay. So are there situations where you may want to calculate vector embeddings manually, or would these almost always be provided back via the third-party service, for example, OpenAI?
Yeah. For the most part today, we're looking at, vectors being created by third-party services. But maybe to elaborate on this a bit more, if you actually think about MongoDB more generally, you'd actually notice that we've had vector support for quite a long time in the form of, geo data, right? And so we've always supported geo data, and those are really just two-dimensional vectors. That is something that you might want to calculate manually, but that's not really what we're talking about when we talk about vector search and high-dimensional vectors for embedding like semantic meaning. And for those, you always need a machine learning model to produce, those high-dimensional vectors.
Yeah. Okay. So, folks, if you're joining in, it's an Ask Me Anything with Ben Flast. You can ask your questions about Atlas Vector Search. We'll try and get those answered. The next question has to do with cluster sync. And this is a question I have as well. So it says, I use cluster sync between my on-prem and my Atlas clusters. If I run vector search against Atlas, will that be synced to my on-prem database?
Yeah, absolutely. So this is a great question. In short, the data will be synced between your on-prem and Atlas clusters, meaning you will have inserted your vectors into your documents. Those documents will live in your database, and those will be mirrored between your Atlas deployment and your on-prem deployment. What will not be synced is the vector index that is utilized to execute vector search. And so that will not be synced. So you can't use $vector search against your on-prem cluster in this scenario, but the data will be synced.
Okay, so I want to ask a follow-up question, and it has to do with Atlas CLI. So as folks will know, if you've been paying attention to the MongoDB podcast and the podcast live over the last couple of weeks, we've had several episodes covering the Atlas command line interface. Some great changes, great features enabled in the latest release, which enable you to launch, deploy, and manage local instances of MongoDB on your desktop or local servers on-prem using Atlas CLI. And as a part of that, you can deploy an Atlas search instance, which is, as you know, managed via a Lucene index, a Lucene cluster. And all of this is done for you with Atlas CLI locally using containers. I'm curious about the support for vector search via Atlas CLI. Is that something that we can use today?
Sure. So great question. So with the Atlas CLI, you can deploy a MongoDB instance locally that does allow you to also use both Atlas Search and Atlas Vector Search alongside it. That is available. But the one thing worth kind of clarifying is the Atlas CLI is really intended for development purposes.
Mm-hmm.
And so you are deploying a single node of MongoDB. So it's not highly available and things like that. It's intended for kind of development and testing. And in this scenario, it would be possible to sync data between your Atlas cluster and that local node and do vector search locally on it. So that is true. And vector search will absolutely work for the Atlas CLI local development experience.
Great. Yeah, good caveat there. If you're using Atlas CLI to deploy local instances, those are for development purposes only, as they're not highly available. Okay, next question, and this one comes from James Presley. I guess this is a follow-up to the previous. So he's asking, are the indexes localized?
I'm not totally sure. I know exactly about what the question is driving at, but let me give a bit more context about how the indexes work and where they live.
Mm-hmm.
So today, when you deploy an Atlas search index, it lives on the same resources that your operational cluster lives on, right? So it lives alongside them, but it takes advantage of the same set of resources that you've deployed in Atlas, and just kind of speaking specifically to Atlas. So you have some collection of data, you've created your index that lives on the same resources. We did just release a new feature into Atlas in public preview called search nodes, which allow you to specify a separate set of resources that your search and vector search indexes will run on. And so when you do that and you configure your cluster, you would set up your 3-node replica set for your kind of core operational use case. So then you would indicate that you want to have, 2 or more additional search nodes, which are where your, vector search index would live and where these queries would be executed. And so these are a new way to allow you to kind of further segment how your different workloads kind of consume resources and basically kind of have those workloads exist separately from your transactional database workloads. So that is a bit about kind of how the indexes relate to the kind of core operational data that you're using, which is for the most part, they are stored on the same boxes, but now that you have the opportunity to add search nodes, you can actually have more control about where they live. That said, if localized is more about kind of, regions or other things like that, then the answer would simply be yes, that, your vector search indexes are always kind of existing in the same region location as your kind of core operational ones when you're kind of deploying them on the same exact kind of system as your MongoDB data. And that even includes the Atlas CLI. So when you deploy locally, those indexes are just living right alongside.
Okay. Yeah. So obviously there's some performance considerations there.
Absolutely.
All right. So this question comes from William Weed. What's the trade-offs in performance between creating smaller chunked vectors versus whole document vectors? You mentioned diminishing returns when increasing the vector dimensionality.
Yeah, absolutely. So this is actually a slightly orthogonal question to the dimensionality itself. So what, users need to do when they're creating workloads using vector search is they need to take, typically bodies of text and chunk them down into smaller pieces and then vectorize them. When you vectorize them, the vector dimensionality stays the same. And the question is just how well does that, vector represent the data that you sent through it? But what I think this question is kind of really hinting at and getting to is that part of the kind of challenge of doing, meaningful search over your data is to chunk effectively such that you have kind of smaller pieces of an overall larger corpus of data that have strong semantic meaning inside of them. And so what you want to do is, if you can imagine you had a page of text about kind of insurance benefits or something like that, you would want to chunk that down into smaller pieces and embed each one of those pieces. And that would mean that like that embedding is focused on just that one chunk that was the source for it and the content within it. When you then do that vector search, you will get that chunk and you'll want to be able to just relate it back to the parent document, which was that larger page. And that's one of the things that MongoDB is so great for, which is that you have the flexible document model. And so you can kind of store and represent and relate all of these pieces of data in a very flexible manner using MongoDB documents. And I would actually kind of call out, there was a new LangChain template put out just the other day that gives a really easy way to get started using this parent-child retrieval mechanism that kind of gets to how to chunk data and how to relate it to kind of original other pieces of data. And then at the end of the day, all of that kind of retrieval ends up feeding some, large language model on the back end with kind of like the right level of context. And so that's kind of a bit into the details of, the chunking part of things. And, separately, the vector dimensionality question is actually kind of a related one, but different concern. And what you'll just want to use is kind of the same embedding model for all of the chunks that you produce.
Okay. So I'm relatively new to this space, Ben, I have to admit, and some of the questions that are floating around in my head, they may be somewhat uninformed, but I'm going to ask them anyway, and hopefully it'll help folks that are joining that have a similar lack of exposure or lack of experience.
For sure.
I mean, essentially, what we're doing by chunking and creating embeddings in our vector search database, we're providing queues which will influence the k next nearest neighbor formula. It'll affect how certain references are deemed to be close. So for example, if I have that insurance document and I want to be able to provide context back to a user query, by providing that document and in a vectorized model, I then am able to more accurately answer questions in that specific context. So the embeddings, the addresses and distances between the terms, that's effectively impacted by the data that I feed into the vector search database. Correct?
I think yes. The one bit I would just like to kind of clarify about that is usually when we use the term context and we're kind of talking about context, we're talking about the idea of feeding context to a large language model. So making sure that the model has the right input to give the user back the answer that they need.
Yeah.
Separately is this kind of concept of vector search, which is the method which that we use to kind of find that context to feed to the large language model. But it is somewhat kind of disconnected from the context in the sense that what you really want with vector search is efficient and accurate traversal of your data to find the relevant bits of context that you will then send over to the language model. And so that's kind of where the split is between them. One is vector search to basically, on top of having embedded this data and kind of defining these distances, be able to efficiently find the right context. And then you take that context and you send it over to a large language model to provide the inference. And just to be clear, vector search has a lot of different use cases, but this is one that people are very excited about today, specifically retrieval augmented generation. And that's why we're talking about kind of sending context to a large language model. But there are other use cases as well.
Okay, that's helpful. Okay, let's continue on with the questions. Does the field an embedding is stored in have to be top level? Can you nest embeddings for different fields in its own object, such as embeddings.plot or embedding.details?
Yeah, absolutely. It's a great question. It's one that we're very excited about. So first and foremost, yes, you can have a vector be nested under any number of levels of field inside of MongoDB, right? You can define a dictionary and have it be kind of a subfield inside of that. What you can't do today is have a vector be a value inside of an array inside of MongoDB. But that is something that we are actively looking at because one of the really exciting opportunities there is to have kind of several vectors inside of an array that all link back to kind of the parent document that all represent different chunks of data. And we're kind of particularly thrilled about this idea because we think it really brings to light the kind of benefit of the MongoDB document model and the flexibility you have when it comes to modeling data. And so that's something that we're kind of spending a lot of time looking at and innovating in. But just to kind of revisit the specific question, you can absolutely have a vector defined inside of a nested field. It just can't be an array.
So really leveraging the value of the MongoDB document model. Great. Good question. The next one has to do with, I guess, competitive offerings. How does Atlas Vector Search compare to Milvus or Qdrant?
Yeah, absolutely. So, Milvus and Quadrant are doing, very interesting things, among others. There's just a ton of innovation happening in this space right now. And we're looking at, all of these offerings similarly. And it's exciting to see just kind of like the amount of innovation and the speed of innovation that's happening. I would say at a fundamental level, the thing that we're particularly excited about with Atlas Vector Search is just the ease of use that you get by combining it with your operational database. And so for a user who's new to any one of these technologies, the ability to just kind of define a vector index on top of your document data is, hugely powerful and so easy to get started and can scale quite elegantly. And so that's really what we're kind of focused on when it comes to Atlas Vector Search and how we see it in kind of like the general space of vector search capabilities. And I think the last thing I'll just say is what we're really responding to here when it comes to vector search as a capability in the database is just demand from our customers. They want this inside of the database. They want the opportunity to just kind of easily define a vector index on top of their data and not have to necessarily sync data between some source of truth and a vector index in a separate system. They just want to kind of like elegantly define it all inside of the same kind of data plane. And that's really where we're focused and particularly excited. Michael,
Sorry, I was on mute. Sorry. So this is about costs, and the question is, what kind of cost impacts should customers be aware of while using vectors? How does Atlas Vector Search impact the cost?
Yeah, absolutely. So the way vector search works inside of MongoDB is that the indexes, as we discussed earlier, are located on top of your same MongoDB cluster. And they consume the same resources that your operational cluster does. So from that perspective, they use the same resources that you're paying for as part of your operational workload. And you just need to kind of scale your workload in order to support all of the different operations you're running on that cluster. So from one perspective, they just consume resources at the same rate that your operational workloads do. When you decide to kind of split and scale with vector workloads running on search nodes, as I mentioned earlier, then that kind of changes some of the scaling profile, but gives you a lot more flexibility, which might allow you to, for instance, kind of scale down the size of the operational cluster infrastructure while scaling up the search dedicated infrastructure. And in addition to that, you can always scale both horizontally via sharding in MongoDB as well as vertically. And so we have options to support any type of scaling that you might want to do. And at the end of the day, all of this is basically consumption-based usage on top of kind of whatever resources you've deployed to satisfy your workload.
So there's no special cost to turn on the vector search capability. It's all cloud-based pricing, just as Atlas.
Exactly.
So as you increase the amount of vectors you store, that's disk space. As you increase the utilization of the vectors via CPU, that's all part of the economics.
Exactly. And one thing that we see is that for a lot of vector workloads, they are more memory intensive than other workloads. And so we're looking forward to giving more options around kind of infrastructure mixes in terms of your deployments to allow you to have kind of low CPU. So you're not, paying for more CPUs that you're not using, but you do need a lot of memory. And so we'll have, low CPU mixes or high CPU mixes to give you kind of the flexibility that you need to run these workloads.
Yeah. So there is a dedicated search node offering. I'm wondering if that makes sense. If your application is targeted toward vector search, does it make sense to leverage a dedicated search node?
Absolutely. Yeah. For most use cases that are kind of very focused on vector search and are, kind of going to scale into larger sizes, you'll probably want to use search nodes. And more specifically, you'll want to use our low CPU search node options.
Are there any considerations around sharding and leveraging the Atlas vector search offering?
In short, no. Vector search, works fine with sharding, just as search works fine. The one thing that I would mention is that you don't have the same type of selectivity via shard keys for the most part when it comes to running vector search, or that shouldn't be the expectation. And for the most part, you will be kind of doing vector search across all of the nodes, and then merging the results at the Mongo OS would be kind of the expectation.
And is that due to the cardinality of the data type that is the vector?
It's more so due to how data is filtered via the vector search stage, and how those filters are applied across nodes.
Okay. Before we leave this topic, are there any other performance considerations that are worth mentioning?
Yeah. So I think the biggest one is just to ensure that you have enough free memory or RAM to load your entire vector index into memory for optimal performance. And so really you can see how large your vector search index is in the search tab, which has kind of the list of indexes and the amount of space that they take up. And you'll just want to make sure that you have enough memory free on the box or on the search node in order to fit that entire index into memory. And it's important to remember that MongoDB is also using memory. And so you just need to kind of keep those, factors in mind as you think about sizing your infrastructure for your specific workload.
Yeah. So performance tuning 101 with MongoDB. Determine your effective working set, which in the case of vector search will incorporate all of your vectors, your embeddings, and then taking into consideration MongoDB's requirements for working set size. So yeah, good stuff. Okay, so we've gone through the list of prepared questions. I want to encourage folks that are watching the stream, if you've got your questions, don't be shy. You can you can put those right in the comments. We'll try and get those answered. Chetan's got a great statement. It's using MongoDB and loves it. Thanks for your support, Chetan. Ben, what's coming down the road map or the pike in terms of vector search?
For sure. So as many of you probably know, the service is currently in public preview, and we are moving as fast as we can to open it up and make it GA so that we can support customers in production for their workloads. And that is definitely kind of the next big milestone for the service. Then we're looking out further into other innovations that we may want to make around kind of the efficiency of storing vectors inside of your documents, or coming up with new approaches to executing vector search to make things faster or cheaper, or less dependent on memory optimizations in that area. And then lastly, I would say just kind of a range of quality of life improvements we'd like to make the developer experience as smooth as possible, and make it very easy for all of our customers to take advantage of vector search, whether that's affordances inside of our drivers or improvements to the UX inside of Atlas. All of these are things that we're looking at and working on right now.
What about ancillary tools maybe even in the creation of the embeddings? Like, are we thinking about that for Atlas?
Absolutely. So that is one of the things that we, are constantly looking at in Atlas itself, but it's also one of the places where we're really excited about all of the integrations that we have with kind of fast and exciting partners inside the space. So we have integrations in LangChain, Llama Index, and Microsoft Semantic Kernel, all of which allow us to kind of be a part of those ecosystems where so much innovation is being driven, which does things like embedding generation at the time of document insert and things like that by reaching out to third-party APIs to create those embeddings. And so we are thinking about the developer experience both from the perspective of someone coming from a MongoDB driver and directly interacting with the interface, as well as someone coming from a third-party application framework such as a LangChain or Llama Index, and working with vector search. And so we're kind of considering all avenues that customers will kind of interact with the end product and making sure that they are kind of seamless and easy to use.
Yeah, I love that focus on the developer. This question from a late user: what use cases can the vector search support?
Sure. So vector search supports a wide range of use cases, both just kind of general semantic search, multimodal search, searching over images and video and audio is also possible. Vector search can be used to implement recommendation systems, do anomaly detection. There's a huge range of options that vector search can kind of help improve or support. And then the one that is kind of very exciting today and kind of coming up with a ton of our customers is really retrieval augmented generation, right? Using vector search to feed context to large language models to allow them to do more informed inference, if you will, and kind of provide private or sensitive company data to an inference model that you wouldn't want to either fine tune or insert into the model itself.
Mm-hmm. Okay. This one from Mark. Are vector embeddings stored and replicated in both MongoDB and Apache Lucene? I guess he's talking about he's talking about Atlas search. The storage impact seems to be quite high.
Yeah, so vectors are stored in the MongoDB documents, and then they are also stored inside of your index in order for us to be able to do the fast traversal of these vectors. It is true that there are storage impacts of storing these things in both places. But the other kind of lens to look at this through is that because your vectors are both stored in an index as well as the database, you're actually getting the durability guarantees for your data by having them inside the database, so that should an index go away or have to be rebuilt, all of that data is immediately available. So there are some really kind of key benefits around having those vectors inside of your documents, even though the index is what is used to search. And, as I mentioned earlier, we'll be looking at ways to kind of do more clever things around compression and just kind of improve the overall efficiency of having to store vectors inside of MongoDB. But fundamentally, there are some kind of key benefits had by having them inside of both your documents and the index itself.
Are there changes being made in WiredTiger, the storage engine, to specifically facilitate vector search?
None to speak of right now, but that is kind of related to some of the improvements we might make in the future.
Okay. All right. James Presley has a question. Would wireframing for vector indexing help with the speed, or is it a constraint of a NoSQL database?
I'm not familiar with the term wireframing in this context. I'd be happy to follow up after, so maybe we can kind of touch base in the community, or the community forums. But yeah, I'm not certain what you're referring to here. But happy to kind of chat on it further.
Yeah, and I'll direct folks that have questions that we're not able to answer here today. The MongoDB community forums, great place. I visit there daily. I'm always trying to answer questions from developers in the MongoDB community forums. You can visit mongodb.com/community. And there is a link, I believe, in the description of this video below. Check those. I also want to remind folks that if you want to dive in, you want to take vector search for a spin, just jump into MongoDB Atlas. It's a cloud-based offering. It starts for free. We have a free forever instance, and you can sign up using the link on the screen here or one of the links below in the description. All right. Another question. Sander has a question. What would you recommend to keep changes to the data automatically synchronized with vector index?
Yeah, absolutely. So one of the awesome parts of vector search inside of MongoDB is that you take your vectors and you store them in your MongoDB documents. Once they are there, on the back end, we automatically synchronize those vectors stored in your documents with the index. And so that is not something you need to worry about at all. All of that is taken care of under the hood. What you do need to worry about is if, for instance, you were to update your data in your documents such that you would want a new vector created or a new embedding generated, then you on the kind of application side would need to update that embedding inside of your documents, but you don't need to worry at all about the idea of kind of replicating data or synchronizing data between the vectors that are stored in the database and the vectors in the index. That happens automatically.
Gotcha. Okay. All right, we're quickly coming up on time. Ben, is there anything else you'd like to share with the audience around vector search before we begin to wrap up?
Not any piece of data. I mean, we covered a ton of different topics here, which I think was excellent. I think the thing that I would just say is, we're thrilled with the service and the feedback we've gotten from the community so far. But, feedback is obviously kind of the lifeblood of our products, and you all using them and enjoying them and finding success with them is kind of the most important thing to us. And so I would just say that, us on the product team, as well as MongoDB in general, would always love to hear your feedback, both, positive and critical. It's, all kind of very much appreciated. And so as and when you're using the service, as and when you get a chance to try it out, definitely come to us in the forums, let us know what you think, ask questions. We're there to help. I myself, in addition to Mike, are always in the forums. And I would say that maybe one last call out is for those people who are kind of maybe new to things and very excited about the technology, but don't know where to start. We have a range of tutorials on our Dev Center as well that can help you get started, both like very basic setup of, I have some documents, I'm creating an index, how do I query? All the way to, hey, I want to build a retrieval augmented generation application using LangChain. And so we have all of those different types of tutorials on MongoDB. And then I would also say that there's, so much kind of evolution and excitement and innovation happening out in the space, in the frameworks like LangChain and Llama Index, and, Microsoft Semantic Kernel, that, those are also places that are great to get started and can immediately take advantage of Atlas Vector Search as well. So that would be just kind of my plug for where to get started and kind of how to think about it, and definitely to just let us know, about your experiences.
Yeah, great. Well, Ben, thanks so much for joining me today, for answering all these questions. I hope the listeners got something out of it. I want to remind folks to subscribe. I find it shocking that people end up here watching a video stream, watching a live stream, and aren't subscribed. So make sure you hit that subscribe button on YouTube or LinkedIn. If you like this content, leave a rating, leave a comment. You can also find more content a lot like this on the MongoDB podcast. We do videos, we do audio, and it's available on all podcast networks. You can find more information at mongodb.com/podcast. And if you're a listener there, share it with a colleague. Ben, thanks so much. Enjoy the rest of your day.
Cool. Thanks, Mike. Thanks, everyone.
See ya.
Bye.